Hey everyone, welcome. If you're involved in building software, you know that testing can be a complex, time-consuming process. In this explainer, we're going to demystify the world of software testing tools, breaking down what they are and how they can supercharge your projects.
So, let's start with a question for you. Does your testing process ever feel slow, repetitive, or just plain chaotic? If you answered yes, trust me, you are not alone. The journey from manual testing, which, let's face it, is often slow and inconsistent, to using the right tools. It's like trading a horse and buggy for a sports car. It's all about becoming more efficient, reliable, and just way more powerful. So, here's our game plan. We're going to kick things off with the big why we even need these tools. Then we'll cover how to manage the whole process, dive into some different kinds of testing, and finally wrap it all up with how to pick the perfect tools for your team. Okay, first things first. What's the big deal? Why should you or your company even invest time and money into these tools in the first place?
Well, it really boils down to 4 huge advantages. You get faster and more efficient. The quality of your testing becomes more consistent and reliable, and honestly, some things, like proper performance testing, are just flat out impossible to do by hand.
All right, now it's really tempting to just jump straight into the cool automation stuff. But hold on. A crucial first step is managing the entire process. Before you run a single test, you've got to have a strategy and get organized.
And that's exactly where test management tools come in. You can think of them as the command center, or the brain, of your entire testing operation. They link everything together.
A really critical concept here is something called traceability. It's all about creating a clear, unbroken chain, all the way from an initial requirement to the test case that checks it and any bugs you might find. This just makes sure nothing falls through the cracks. It's all about total accountability. All right, now for something that honestly sounds a bit like magic when you first hear it. You can actually find bugs without ever running the program. This powerful technique is called static analysis.
And this slide really nails the core difference. Think of static analysis as prevention. It's like checking the blueprints of a house for flaws before you start building. Dynamic analysis, which we'll cover in a bit, is more about detection, finding problems while the software is actually running.
So one of the key things these static analysis tools hunt for are data flow anomalies. The best analogy is that they're like subtle grammatical errors in your code. A compiler might not catch them, but they often point to a much deeper problem that could cause a crash later on.
Let's look at a real example. This snippet of C++ code is supposed to swap 2 values. Now, to the human eye, you might glance at it and think, yeah, that looks fine. But a static analysis tool can scan this in a fraction of a second and instantly flag some suspicious activity.
And these are the exact kinds of issues it's looking for. These are the silent killers of code quality. So, in that code we just saw, the tool would flag a U anomaly because the help variable was used before it was ever given a value. It would also spot a DD anomaly for the max variable. These are the subtle but really critical bugs that these tools are built to catch.
Okay, now we get to the thing most people think of when you say test tools, and that's automating the actual running of the software. Time to make the robots do the work.
A really common starting point for teams is using capture/replay tools. The idea is super simple, and honestly, very appealing. You, a person, perform the test once, clicking buttons, typing stuff in, and the tool records everything. Then it can replay those exact actions perfectly, over and over. But that simplicity can be a bit of a trap.
And that leads us to this quote, which is so true. If your underlying testing process is a mess, if it's sloppy and disorganized, just throwing automation at it won't fix it. You'll just get bad results faster. You have to have a solid process first.
Okay, let's switch gears to a type of testing that you literally cannot do manually. And that's checking how your system performs when it's under a ton of strain.
Right. These tools are absolutely essential for any website or app that has a lot of users. What they do is they create a synthetic load. They simulate thousands, even millions of users hitting your application all at once to answer one critical question. Will our system survive on its busiest day, or will it fall over and crash under the pressure? So we've covered a bunch of different kinds of tools. But the million-dollar question is, how do you choose the right one for your team and make sure it's actually a success?
A huge part of this is understanding the economics. Take a look at this chart.
It shows the typical payoff for automated regression tests, the ones that make sure a new feature didn't break something old. At the very beginning, that cost is high. But look what happens. After just a few runs, the cost plummets, and the savings compared to doing it manually just get bigger and bigger.
But, and this is a big but, it is not risk-free. All those amazing benefits can be completely wiped out if you fall into one of these common traps. Things like having totally unrealistic expectations, or, like we said before, trying to automate a process that's already broken.
So to avoid those pitfalls, you really need a disciplined process. Following these 5 steps, from figuring out your requirements, all the way to running a trial on a real project, this is how you make sure you pick a tool that actually solves your problems instead of just creating new ones.
And that really brings us to the final takeaway. A tool is only ever as good as the process it supports. Choose wisely, and it can be a powerful investment that pays off for years. But if you choose poorly, well, it's just going to become another expensive piece of software that sits on a digital shelf collecting dust.